Hello everybody and welcome to the Ecology Lab. This lab will be focusing on predator pressures, specifically how natural selection via predator pressures impacts natural phenomenon and explaining the mechanisms and patterns behind evolution. For this specific lab, we will be focusing on gallflies and how they make galls in goldenrods, and how parasitoid wasps and birds predate on these gallflies. But first, we will be looking at some histograms. There's two histograms on this chart, one showing petal length of cherry trees and one showing the height. The y-axis of both histograms is the frequency. In order to read this, we can see that there's 25 cherry trees petals that are 1 to 1/2 centimeters long, and that there's 10 cherry trees that are 75 to 80 feet tall. Histograms are also a useful way to visually display central tendencies in the data. Central tendencies are where data typically clusters together. In these two histograms, the petal lengths that are 1 to 2 centimeters, as well as 4.5 to roughly 6 centimeters, is the central tendencies. And then for the heights, it's 70 to 85 feet. Central tendencies can also describe the mean, median, and mode. And opposite as well, mean, and mode can describe the central tendencies. However, not all data can be expressed through these due to the extremes. Mean is the sum of all values divided by the number of cases. The median is the middle number of all cases in order, and the mode is the most frequent value. The mean can be thrown off from these central tendencies by extremes in the dataset. Bimodal datasets is where you have data on both sides of the extreme, and mode being the most frequent value is not always represented by the central tendencies. They're also useful because they can show us how much variation there is in each data set